Hello friends, today we are going to see some of the applications of TTT diagram, that is Austepering and Martempering. The figure indicates Austepering process superimposed on TTT diagram. This is a special heat treatment process in which austenite is transformed into bainite as shown here. Here it is initially austenized and it is then transformed into bainitic structure. The cooling sequence for Austepering is superimposed on the TTT diagram as shown in this figure. In general, austenite is either transformed into perlite or martensite depending upon conventional heat treatment process involving continuous cooling. Austepering consists of heating steel to above austenizing temperature. So in case of hyperheated hot steels, the austenizing temperature is above AC3. Hypoheated hot steels, it is above AC3. It is then quenched in bath maintained at constant temperature above martensitic start temperature and within the bainitic region, that is in the temperature range of 200 to 400 degrees Celsius. So that zone is shown here. The steel is then quenched and maintained at constant temperature in bath itself till all the austenite is getting transformed into bainite. So till this point there is no any transformation of austenite into complete bainitic structure. It is still in a metastable austenitic phase. So it will start transforming at this point, at this temperature, constant temperature, and at this time period. So it will take some time to transformation to occur, and after this time period reaching, the bainitic structure is formed. After complete transformation, steel is taken out from bath and it is cooled in air or at any desired rate to room temperature. So it is followed by slow cooling. So ultimately it will be giving a lower bainitic structure. Since the process involves transformation of austenite to bainitic structure at constant temperature, it is also called as isothermal quenching or isothermal hardening treatment process. Depending upon temperature of transformation, the product may be upper bainite. The most important advantage of Austepering is it produces structure and properties very much similar to tempered martensite without involving in martensitic transformation. So as here you can see there is no any martensite as is formed here. Because of constant holding, austenite will be getting transformed into bainitic structure. Also the dimensional stability of component is more due to absence of retained austenite, because there is no any presence of retained austenite because the austenite to bainitic transformation has finished to 100%. However, it has some limitations or disadvantages. The hardness produced is not so high as that produced by martensitic transformation. Then since the critical cooling rate has to be exceeded during cooling, the process is applicable only to slightly hardenable steels. Then the holding time are much more longer as it is very much lengthy process for constantly holding temperature. Hence the process is expensive in nature. another application of TTT diagram is patenting. The special heat treatment given to medium carbon, high carbon and low alloy steels wire rod is called as patenting. The process consists of heating the material well above austenizing temperature, that is up to this temperature, to ensure formation of homogeneous austenitic structure. After soaking for sufficient time period, the steels are then quenched in quenching bath maintained at constant temperature. So that temperature is up to 550 degrees Celsius. For given steel, the quenching bath temperature is kept in vicinity of nose of TTT diagram. This results in transformation of austenite into a fine perlitic structure. So here it will form fine perlitic structure. Once the transformation is complete, this results in transformation of austenite into perlite. Then the steels are cooled either in air or by spraying water. In some cases, a small amount of upper bainite is formed. There might be chances of formation of bainite. Lead bath or salt bath are commonly used for quenching the steels to avoid oxidation. The common temperature for bath ranges from 450 degrees Celsius to 550 degrees Celsius. The process is mainly used for spring wires, ropes, etc. The higher the soaking temperature, which is always above austenizing temperature, the greater is the stresses developed, making the steel prone to distortion and quenching cracks. So that may lead to a formation of some defects. As low carbon steels can be drawn heavily in as annealed condition, patenting heat treatment is not employed for such kind of steels.